Good morning, students. We already know the usage of whole numbers for the purpose of counting. And we also know how to represent part of something using fractions 2 by 3, 3 by 4, 5 by 7, etc. All these fractions are called common fractions. Which are called common fractions? 2 by 3, 7 by 4, 9 by 10, 15 by 28, etc. These are all called common fractions. Now, there are some other fractions. I am going to write on the board. See, 5 by 10, 7 by 100, 23 by 1000. These are all called decimal fractions. Decimal fractions. So what are decimal fractions? Fractions whose denominators are 10, 100, 1000, 10,000, etc. That is, the denominators are powers of 10 are called decimal fractions. All the decimal fractions can be called as common fractions. But you can't call all common fractions as decimal fractions. That is, all common fractions are not decimal fractions. Why? Because common fractions can have any denominator. It can be 7 or it can be 8 or it can be 10 or it can be 100. But whereas decimal fractions can have only powers of 10 as denominators. That is why you can call all decimal fractions as common fractions and all common fractions as can't call as decimal fractions. Okay. Now, there is another way of writing these decimal fractions. For example, if you take 5 by 10, you can write this as 0.5. And if you write 7 by 100, you can write this as 0.07. And if you take 23 by 1000, you can write this as 0.023. So writing a decimal fractions like this is possible. Then these are all called decimal numerals. Decimal numerals. So when a decimal fraction is written in this form, then we can call it a decimal numeral. If it is in the form of a fraction, we call it a decimal fraction. Now, what are the place values we have in decimal numerals? What are the different place values we have in decimal numerals? Now, let us see. And this synopsis is all about this decimal numerals. Now, if you take 0.5478, generally we count places in whole numbers from right side to left side. But while saying the place values in decimals, we say it from left to right. That is, this 5 is in tens place. Tens place. And which is nothing but its place value is 1 by 10 or 0.1. And next, if you take 4, It is in 100 place. 100 place. And it is equal to 1 by 100 or 0.01. And if you take 7, it is in thousands place. Thousands place. Which is nothing but 1 by 1000. That is equal to 0.001. So these are all the different place values you have in decimal system. So what are those place values? If you write in brief, the first place is 10th place. And the next place is 100th place. And next place is 1000th place. And next place is 10,000th place. And so on. So the values are 10th place value 1 by 10, which is nothing but 0.1. Next 1 by 100, 0.01. 1 by 1000, that is nothing but 0.001. 1 by 10,000, that is nothing but 0.0001, etc. So that is the next place value will be lakhs place value, 10 lakh place, and so on. So this is how we have place values in decimal numerals. Now, how to write a decimal in expanded form? We have the experience of writing a number in expanded form in whole numbers. For example, if you take 548, we write it in expanded form using the place values 5 into 100, 4 into 10, 8 into 1, like that. So, how to write a decimal numeral in expanded form? And before going to that, are all the decimals less than 1? Or can we have decimals which are more than 1? Yes, we can have. In case of fractions, we have fractions whose value is less than 1, whose value is greater than or equal to 1. Similarly, in decimals also, we have decimals which are greater than 1 also. If you take 7.54 and it is greater than 1. So it is 5 is in 10th place. We count place values like this. 5 is in 10th place, 4 is in 100th place, and so on. So now let us see how to write a decimal numeral in expanded form. Expanded form means, for example, first I write 0.379. If you want to write this in expanded form, we use place values whenever we want to write a number in expanded form. So 3 is in 10th place. So 0. 3 is in 10th place. So 3 into 1 by 10. Plus 7 is in 100th place. 7 into 1 by 100. Plus 9 is in 1000th place. So 9 into 1 by 1000. And if you want, you can write here 0 into 1 because units place is not there. Units place is 0. Whole part units place is 0. So you can write 0 into 1 also. Now this is how we write a decimal number in expanded form. If you have some 15.947. Now we have here whole part. Every decimal will have two parts. The part that is on the left side is called whole part. That is, here 15 is called the whole part. And 0.947 is called the decimal part. So this, if you want to write in expanded form, 1 is in 10th place. Whole part we write as we use it to write whole numbers. Plus 5 is in 10th place. 5 is in 1's place. 5 into 1. plus 9 is in tens place, so 9 into 1 by 10, plus 4 is in hundredth place, 4 into 1 by 100, plus 7 is in thousandth place, so 7 into 1 by 1000, so on. Or else you can write the same in another way also. 1 into 10 plus 5 is in ones place, 5 into 1 plus 9 into 0.1 plus 4 into 0.01 plus 7 into 0.001. The above number can also be written like this. So this is how we write a decimal in expanded form using their place values. So every decimal will have two parts. One is, for example, if you have 17.984, here 17 is called the whole part or integral part, and this 984 is called the decimal part. Decimal part. And there are decimals where you don't have any whole part. Their value is always less than 1. If there is no whole part, it is nothing but 0. So it is customary to write 0 whenever there is no whole part. That is 0.7, 0.98, 0.1743, etc. All these are decimals where there is no whole part. Whole part is 0. And the value of all these decimals is always less than 1. And also, this type of decimals are called pure decimals. Pure decimals. Why? Because there is no whole part at all. So they are purely decimals. They are purely decimals. Now, how to read a decimal number or how to read a decimal numeral? Is there any difference in reading a whole number and a decimal numeral? Yes, there is a difference. As you might have noticed, I have already read some numbers. You have this decimal. You want to read it. And when you want to read, we read the whole part as we use it to read. 15, 15. There is no problem with it. But when you are reading a decimal part, you have to read each digit separately. That means you have to read 15.784. That is how you have to read this decimal. You can't read this 15.784. That is wrong. This is not 784. It is 0.784. So after the decimal point, whatever digits you have, those digits are to be read separately. That is how we read decimals. Suppose you have 6 point this. And how we read this? 6.9324. So whenever you are reading a decimal, how you have to read it? You have to read it after the decimal point. Each digit must be read separately. That is how we have to read it. So we have to read the above decimal 15.784 and the next one 6.9324. If you have one more, this one we have to read as 0.1235, etc. So this is how we read a decimal numeral. Now, again in decimals, are there any different types? Yes, you have. In fractions, if you remember well, you have like fractions and unlike fractions. Like fractions means fractions which have the same denominator. Whereas unlike fractions means fractions which have different denominators. In the same way, in decimals also you have like decimals and unlike decimals. So which are called like decimals and which are called unlike decimals? So let us see. Like decimals first. Like decimals. Like decimals. So which decimals are called like decimals? Decimals which have the same number of digits after the decimal point are called like decimals. Which are called like decimals? Decimals which have the same number of digits after the decimal point are called like decimals. So let us see examples. 0.94, 0.23, 1.57, 254.13, etc. If you notice, all these decimals have same number of digits after the decimal point. In the first one you have 2, second one you have 2, third one all decimals have the same number of digits after the decimal point. So such type of decimals are called like decimals. And next we have unlike decimals. So by this time you might have already got what are called unlike decimals. Yes, you are correct. Exactly the decimals which have different number of digits after the decimal point are called unlike decimals. For example, see 5.4, 3.23, 7.48, 7.48, 9.43, 74. These are all unlike decimals. Why? Because all these decimals have different number of digits after the decimal point. The first one has only one digit after the decimal point, and the second one has 2 digits after the decimal point, third one again 2, but fourth one again you have 4 digits after the decimal point. So all these together are unlike decimals. But we can convert unlike decimals into like decimals. We can convert unlike decimals into like decimals by placing zeros at the end. By placing zeros at the end. That of course I will say later in the next synopsis. So this is how the decimals are classified. Like decimals and unlike decimals. I already told once about pure decimals. That is where there is no whole part. Those are called pure decimals. Now let us see what about equivalent decimals. Another type is there. Equivalent decimals. Equivalent decimals. So what are these equivalent decimals? Equivalent decimals means decimals whose value is same are called equivalent decimals. For example, 0.5, 0.50 are equivalent decimals. Why? Because 0.5 and 0.50 are same. There is no value for the end 0. So if you cancel that end 0, it also becomes 0.5. So decimals whose values are same are called equivalent decimals. So like this, decimals are classified into like decimals, unlike decimals, equivalent decimals, and of course I told pure decimals. Next, how to compare decimals. So whenever we are going to learn about a new number system, we must know all these. We must know how to compare them. We must know how to add them. We must know how to subtract. All these we must learn. All the 4 fundamental operations, how to perform on them. So now let us see how to compare decimals. Comparison of decimals. So what is meant by comparison of decimals? Of the given 2 decimals, you must be able to say which is big and which is small, and later using which we can write the decimals in ascending and descending order. So let us see how to compare decimals. Now I'll take an example here. Example 1. Find the greater one of 7.494 and 5.678. So whenever we want to compare decimals, first we start with whole part. If the whole part can decide which is bigger and which is smaller, there ends the matter. Now here, if you look at the whole part, here is 7 and here the whole part here is 5. So 7 is greater than 5. So immediately you can say 7.494 is greater than 5.678. So the business is over there itself, because the whole part itself decided of the given two decimals which is bigger. Next, let us see one more. 0.54 and 0.5432. Now we have to decide of these two which is bigger, because we are asked to find greater one of. Now if you look at whole parts, 0, 0. Whole parts are same. So here we can't decide using whole parts of these two which is the bigger. So immediately we will go to 10th place. Here we have in 10th place 5 and here we have in 10th place also 5. So here 10th place can also not be able to decide which is bigger of these two decimals. So immediately we will go to the next place, 100th place. Here 100th place is 4 and in the second decimal also 100th place is 4. So of these two decimals, to decide which is bigger, whole part is not helpful, 10th part is not helpful, 100th part is also not helpful, as all the three are same. So next we will go to 1000th place. Sir, there is no 1000th place here. Yes, you can imagine a 0 there. There is no 10th place, 1000th place there. But in the other number, what is the 1000th place you have? 3. So we know 1000th place in the first decimal 0 and 1000th place in the second decimal is 3. We know 0 is less than 3. Therefore, you can say 0.54 is less than 0.5432. So this is how we compare decimals. When it is possible, we complete the comparison using the whole part only. When it is not possible, we will go to 10th place. If 10th place decides the matter, there it will end. If it is not possible using 10th place also, as happened here, we will go to 100th place, then we will go to 1000th place, so on. And then finally we decide of the given two decimals which is bigger and which is smaller. And we use the same concept for writing the decimals in ascending and descending order. So now in this synopsis we learned what is a decimal fraction and what is a decimal numeral. And what is that? A decimal fraction is a fraction whose denominators are powers of 10. That is 10, 100, 1000, 10,000, etc. If a decimal fraction is written in the form of a numeral, then it is called a decimal numeral. And we have also seen the different place values we have in decimal numerals. Those are 10th place, which is equal to 1 by 10 or 0.1. 100th place, which is equal to 1 by 100 or 0.01. 1000th place, 1 by 1000. which is equal to 0.001, and so on. And also we learned how to write a decimal numeral in expanded form using their place values, how to read a decimal. And here I told you we have to read the digits after the decimal point individually. When you want to read this decimal, you have to read 0.54, the other decimal 0.5432. And we have seen which are called like decimals, which are called unlike decimals, and which are called equivalent decimals. Like decimals are those decimals which have same number of digits after the decimal point, whereas unlike decimals are those decimals which have different number of digits after the decimal point, and equivalent decimals are those decimals whose values are same. And finally, we have also learned how to compare decimals. That is, of the given two decimals, which is bigger, which is smaller, that we know how to do it. We compare first whole parts. When it is not possible with whole parts, we go to 10th place. When it is not possible with 10th place, then we will go to 100th place and compare. And finally, we will decide which decimal is the bigger and which decimal is the smaller. And using the same concept, we can write the decimals in ascending and descending order also. And we have also learned how to write unlike decimals into like decimals. I told we haven't learned. We can convert unlike decimals into like decimals. And this we are going to learn in the next synopsis, where you are going to learn how to add, subtract, multiply, and divide decimals. Okay, so have a good day. Thank you.